So this video is on dipole-dipole forces. First, we should talk about charges. Whenever you have two different charges next to each other, they will feel an electrostatic force that will cause them to attract one another. The chopper of the diagram shows this attraction. Two like charges will feel an electrostatic force of repulsion, as shown through the bottom two rows of the diagram labeled repel. So polarity. First, electronegativity is a measure of the tendency of an atom to attract electrons. According to Fonkelbrish, which is a generic mnemonic for some common elements, fluorine is the most electronegative and hydrogen is the least. So when two elements with different electronegativities form a bond, their bond is now a polar bond. And when a molecule is polar, it can form dipole-dipoles. So in hydrochloric acid, we can use Fonkelbrish to say that chlorine is more electronegative than hydrogen. Therefore, the electrons are more likely to be near the chlorine at any given point in time, giving hydrochloric acid this polar bond. On the right side of the diagram, you can see that the hydrogen has a partial positive and the chlorine has a partial negative. This can also be written with an arrow, as seen on the left side of the diagram, with the tip of the arrow pointing towards the more negative side of the molecule. But be careful, because sometimes a polar bond isn't just enough to make a molecule polar. If the molecule is symmetrical, like carbon dioxide, which is linear, the bond polarities will cancel out and the molecule will no longer be polar. But for sulfur dioxide, since it has a bent shape, the molecule is polar, with the partial positive at the sulfur and partial negative towards the bottom of the molecule near the oxygens. Only the sulfur dioxide will form dipole-dipole interactions here. So we can see in the periodic table that the range of electronegativity values is from about 0.75 to 4. If the difference between the two electronegativity values is greater than 0.4, then the bond formed between them is polar. For carbon monoxide, the difference between their values is about 0.9, which is greater than 0.4. As said earlier, opposite charges attract and like charges repel. Therefore, two carbon monoxides could attract one another as shown. The oxygen in one molecule will attract the carbon in the other. The red dotted line is a dipole-dipole force. But remember, the bond, which is an intramolecular force, is much stronger than the dipole-dipole interaction, which is an intermolecular force. Hydrogen bonds are the strongest type of intermolecular force, and they are a type of dipole-dipole force. Hydrogen bonds, which aren't actually bonds, involve hydrogen and either fluorine, nitrogen, or oxygen. Some examples of molecules that exhibit hydrogen bonding are hydrofluoric acid, water, and ammonia. In particle view, atoms that have a partial negative will be faced towards the atoms that have a partial positive. In the diagram, it is shown by the oxygens facing towards the hydrogen and away from the other oxygens. In water's case, it can form two hydrogen bonds because it has two hydrogens, but hydrofluoric acid can only form one hydrogen bond. It makes sense that water has a higher boiling point than hydrofluoric acid because of the intermolecular forces.